Thank you very much for the introduction. Can I check that I'm sharing everything okay and I'm in presenter mode?
Absolutely, it's all good to go.
Perfect. So thank you very much for the opportunity to speak today, and I've really enjoyed the presentation so far. I'm going to talk to you today about a project that we coordinate at Ulster, which is all about a training package, a training program for responders and predominantly firefighters in hydrogen safety. But before I do that, I want to give a little bit of context in terms of why Ulster University are leading this project and where I sit in terms of the activities there. So at Ulster, we have a Hydrogen Safety Engineering and Research Centre, HySafer, where the focus is very much on hydrogen safety research. So whilst I'm picking up on one aspect today, it is cross-cutting across all the projects that we've heard about and different applications. But at Ulster, the focus is very much hydrogen safety research and education and training. I mean, we need safety levels. People need to be safe. We need those levels to be at least equivalent to those that we have with our existing fossil fuel applications. And hydrogen's no more or less dangerous, but we need to understand it. And if we need to use that understanding to inform design, regulations, code standards, and guidance. And that's really where the project I'm going to talk about comes in as well. So I'm part of the HySafer Centre, which is a team of 12, and it's led by Professor Vladimir Malkov. And what we do there ranges from fundamental and applied research, so understanding the phenomena associated with potential hydrogen incidents, so when something goes wrong, and that predominantly relates to when you have a loss of containment. So that might be a leak, how that gas spreads, if it ignites, what does it do? How does it behave indoors versus outdoors? Indoors in particular, my colleagues are involved in the High Tunnel project as well, which is all about the safe use of hydrogen vehicles in tunnels and parking and garages and so on. So the work that we do, it's analytical and computational modeling, so CFD, computational fluid dynamics, but it's collaborative with international both research and industrial partners as well. We have 11 ongoing collaborative projects, and they include HyResponder, which is what I'm going to talk about today. But I wanted to give a bit of context in terms of why Ulster are leading this project and where we fit in. So at HySafer in Ulster, the key goals really are to close knowledge gaps, to inform technology design together with industry partners, to use the research to inform codes and standards and guidance. So what are we doing with that information and where is it going? And also to deliver education and training in hydrogen safety. And it's those bottom 2 points in terms of development of guidance and tools, simple tools for hydrogen safety and education that the HyResponder project brings in or covers. So HyResponder, it's a European train the trainer program for responders. It's just over 3.5-year project. It has a budget of 1 million. Ulster are a coordinator, and it brings together 16 partners from 10 countries. And those partners span, there's industrial involvement, academia, but also fire and rescue schools, an overarching organization for fire and rescue authorities as well. And the real aim of this project is to develop and implement a sustainable, so we want something that is going to continue when the funding stops, train the trainer program in hydrogen safety for responders across Europe. So it's about developing and updating a training package, training trainers in hydrogen safety from countries across Europe. Those trainers are then going back, delivering national level training workshops to introduce the package, and then looking at how the training can be rolled out and embedded within their national or regional setup as well. So the training that I mentioned, it covers 3 different elements, and I'll pick up on this again later. So there's an operational hands-on training. So we have a unique training facility that our colleagues at Fire School in the south of France have to train firefighters in dealing with hydrogen incidents. There's virtual reality training and there's educational training. So that underpinning theory. So that's where Ulster University have come in with the delivery of those lectures. And all of it is focused towards responders. We're bringing together that European network of responder trainers because it's at different levels, dependent on the country. Training trainers from at least 10 European countries. There's 10 countries represented in the project, but we have wider involvement through our stakeholders. And that's very much an open door for countries who are not directly involved at this point. We're translating the materials because what we have found is there's such variance. So you have volunteer firefighters up to those specialized hazmat officers with engineering degrees, and there is a need for training materials in the local language. So part of the project is the development of training materials in 8 different languages, and then delivering this training across 10 different countries. And it's not just about the scope of the project and the time frame. All of the materials are going to be available online and beyond the project as well on a dedicated e-platform. We also have a European emergency response guide that I'll come back to. This is for responders for dealing with hydrogen specific incidents, and an update of that document is a key part of the project. So I've already mentioned there's different training elements to this project for responders. So there's that hands-on training. So there is a bespoke training platform in NSOSP, a French fire school in France. And we have updated that within the scope of the project to include cryogenic spills as we move towards liquid hydrogen applications. There's the educational training, and we have at Ulster led that element and looked at how we can split lectures or stratify them, look at the different learning levels and reach a consensus of how we can try and identify learning levels that are common across the fire and rescue services in Europe. There's VR, virtual reality training exercises as well that have been developed. And all of this is underpinned by an emergency response guide. So what do you do in a specific scenario and how do you react to it? And the research we've done at Ulster in terms of hydrogen safety is fed in to some of this guidance and the training as well. And we have a beta or a trial version of the platform. It's at its basic stage online at the moment where some of those materials are developed. Mentioned a little bit about the challenge of the different learning levels. We found that we want the information that we're providing and the training that we're providing within the project to be useful and fit for purpose, and trying to present that in a usable fashion has been a challenge because we have, as I mentioned, volunteer firefighters up to specialist level. So how do we develop materials that are usable by all? And we've been working with the different organizations throughout Europe to develop packages at different levels and to look at how that works on a regional or national level with their existing training programs. There's a European response guide that I've mentioned, the EERG, and it's a guide intended to be used by emergency response personnel when responding to a hydrogen incident. It has been updated within the scope of this project to account for liquid hydrogen applications, and it is open to public input. So if there are any responders on this meeting today, we welcome your input and feedback, and we will take it on board. So what stage are we at now with the project? We have our trainers have undertaken virtual training. This project kicked off in January 2020 when COVID was not even on the horizon. And just as it started with all these grand plans for in-person training, the pandemic scuppered some of those plans. So we have done our educational training. The lectures have been rolled out to trainers online, but we want to follow up with that with hands-on training at our platform in France in the summer. And then those trainers will take that training and bring it back nationally and deliver introductory workshops in their own languages to introduce it. So there will be a series of workshops across Europe in 22-23 where trainers are introducing this translated material that's been translated into 8 languages. And those materials, as I've said, will be freely available in advance of those workshops, but beyond the project as well. And there's plans on, it's not just about having 10 workshops and then that's it. It's where does that information go next? And how is hydrogen safety training embedded within the training programs for responders across Europe. And that really varies. The system is so varied from country to country. So we're working with each region to have a sustainable plan in place to maximize the impact of the training. I mentioned the platform. So this is effectively like a website, a landing page where public facing, where we're putting this information. It is at its early stage, but the materials are available online at the moment in English. We thought we'd have wonderful interactive modules, but the feedback we're getting from responders, firefighters, is they want this to be almost like a textbook, a validated bank of information from which they can select the key information they want that fits with their existing training. But what we have on the platform are some lectures in PDF format, training sequences, online tools, and I'm going to come back to that in a minute, because while I'm talking about responders specifically now, I think there's some elements of this that may be of interest across the piece to those on today's call. And the translated materials will be there within the scope of the project. So I mentioned online tools. I'm going to pick up on those a little bit, because again, I think they'll be of interest perhaps for those on the call today. So on the HyResponder e-platform, there is an e-laboratory. You need to request access, but it's free. And if you fill in the access request form, you'll be given unique logon details later today. So what is in that e-laboratory are a series of tools that we use to underpin the HyResponder training and indeed hydrogen safety education at Ulster. But there are a number of different applications for this. So some of these tools are for calculating hazard distances. So what I mean by that is, for example, if you have a hydrogen leak and you want to know at what point or what the extent of your flammable jet is, so how far you could stand away from it with the source of ignition, these are the tools that would enable you to estimate that. Or if that leak was ignited, how long might that flame be? Or what might be the distance at which you would have a certain temperature. So these are useful for other purposes as well. So if I take, for example, the similarity law for concentration decay, what that effectively is you want to know how long your flammable jet is, how far you can stand away from your leak with an ignition source and not have ignition. This tool allows you to put in your storage pressure. So if you had a tank, for example, what the leak size, so your orifice diameter, and then what distance or what percentage of hydrogen you're interested in. So I put 4% there as being the lower flammable limit. And you can see that tool, it predicts that there would be at a distance of just over 9.6 meters away, then you're at 4% and decaying further. So some tools there, and all of those have been designed based on research at Ulster. And there's information there in terms of where that supporting research is published within each of those tools. So for those of you who are perhaps not responders or interested in responder training, I think some of these tools may be of interest also. So to finish up, HyResponder, going back to the responder training, what we expect the overall impact of it to be is this e-platform. So materials online beyond the scope of the project. A unique hands-on facility at NSOSP, so our fire school in France, for training of responders in hydrogen safety. And that's been used as a blueprint for other countries. I know our Norwegian colleagues are looking at development of a similar platform to train their firefighters based on what the facility in France. There's a roadmap in place for a standard training package to try and ensure that we are rolling out training across Europe in hydrogen safety for responders, but also materials will be available in 8 languages for fire schools to customize and to align to their existing training. And we are looking at how we bring that forward beyond the scope of the project and maximize its impact. And those online tools I've just picked up on are available to support training, but they're available to all stakeholders. So I would encourage you to have a look. And if you're interested, to apply for access to those. And the European Emergency Response Guide is in place for responders globally. So I think I've gone through that quite quickly. I was aware of time, but I'd like to thank you for your time today, and I'll hand back to the chair.